Okay, so this video is about odd and even functions. Before we start, I want to review that. So odd functions have the property that they are symmetric about the origin. And that means stuff like this. Like if I had some picture that kind of did this right here, then symmetric about the origin would mean if I rotated this thing 180, it looks exactly like it on the other side too. So it would do something like that, right? If there was a hole right here, then there'd be a hole right there. So that would be symmetric about the origin. Okay. They also have this property. If I plug in negative x into the function, then that's the same thing as plugging in x, except the entire value of the function has to be negative then. And then even functions, those have symmetry about the y-axis. So if I had some function that did this, then I'd need some function that does the same thing on the other side, just a mirror image across that. That doesn't look like a mirror image, but you get the idea. And so those have the property, if I plug in negative x, it's exactly the same y value as if I just plug in x. Now I'm going to be talking about trig functions and using theta all over the place. So I'm also going to write this in terms of theta. So if theta was our x instead, then we get this property. Or these versions of the properties for odd and even. Okay, so let's look at sine. Right, so here's sine. Oof, this is terrible, but I'm not going to redo it right now. Okay, so here's sine. And you can tell pretty quickly this thing's symmetric about the origin right here. If I rotated 180, I get the same picture. And so sine of theta, right, y equals sine theta, that's going to go into the odd category. And if sine goes in there, think about the fact that the one related to sine, which is cosecant, that one also has to be an odd function because it's based directly off the graph of sine. So cosecant theta is going to go into this category too. Okay, let's look at cosine then. So let me clear out all this stuff. I'm going to lose my graph, aren't I? Yep. Okay. Oh well, I'll just do this from scratch anyway. Okay, so if we look at cosine, cosine does this, right? Well, you can tell that that's symmetric right across the y-axis. So in the even category, I'm going to put cosine theta. And since, let me use a different color. Since its reciprocal function is secant theta, and secant theta is built basically right off the cosine graph, and secant theta has to be an even function. You can tell secant theta is also symmetric right across that line. Okay, so there are those. Now let's look at tangent and cotangent, and then we've covered all our bases. So here, let's look at tangent. So tangent is centered around 0, 0. And then those asymptotes are pi over 2 and at pi over 2 and negative pi over 2. And so tangent does this. And you might be able to tell pretty quickly just by examining this central piece right here that this thing is symmetric about the origin. And so since it's symmetric about the origin, that makes it an odd function. And then cotangent is actually built out of the tangent function too, so we're going to guess that it's going to be odd. But let's actually graph cotangent. Oh, well, lost it. Okay, so cotangent, there's an asymptote right here, and then cotangent comes up like this. Oh no, sorry, wrong way. comes down like this. And this would be pi over 2 right here, and then another asymptote at x equals pi, or theta equals pi. And then it repeats over here. You might not be able to tell what kind of symmetry this is. It's definitely not just reflected across this axis here. But if I take, let's see, how can I select this? Well, yeah, here's what I'll do. I will flip this thing horizontally, and then I'm going to flip it vertically. And you might be able to tell you get the same exact picture back. And flipping horizontally and flipping vertically is the same thing as rotating by 180 degrees. So that means that it's also reflected about the origin, or symmetric about the origin. So cotan theta also goes in the odd category. So there are my odds, there are my evens. And if I use this f of theta type property up here, well, the even functions, let's take like secant as an example. Well, f of theta equals secant theta. So if I plug in negative theta, that's the same thing as just saying it's regular theta too. It's the same value. And cosine of negative theta is the same thing as cos theta. We talked about this a little bit in the last chapter. Whereas over in these functions, if you take like sine of negative theta, that's like pulling out the actual negative. Cosecant of negative theta equals negative cosecant theta. All these things are the same. Tan, negative theta, you pull out the negative instead of throw the negative away. And cotan negative theta equals negative cotan theta. So these are the odd functions. These are the even functions here. And those come in handy when you're doing various trig identities, and you have like sine theta at times sine of negative theta somewhere in your proof. And well, you can't combine them the way that they are, but you could turn this into sine theta times negative sine theta. And then when you multiply these guys together, then you can say, oh, well, this is negative sine theta squared, which we write as sine squared theta like that. That negative just moves in the front. So that helps a little bit, with simplifying certain expressions. Okay.